Hello everyone, I hope you are doing well. I welcome you all in the next lecture of 12th class NCERT Mathematics. In this lecture, I'll discuss some more questions of exercise 1.2 of NCERT Mathematics. So without further ado, let's get started. So what question says? Question number 3. We will discuss. Prove that the greatest integer function which is defined from R to R given by this one is neither 1 nor on 2. We need to prove this thing, okay, where this one not the greatest integer function. Okay, so first of all I will explain what is the greatest integer function, what is its graph, what is its range, and what is its domain, like that things. Okay, so here we have function R to R. It is defined, and f of x is greatest integer of x. And how we can define it? If x is in between 0 and 1, okay, then the value of this function is, then it will provide 0 value, okay. And if x is in between 1 and 2, it will provide 1 value. Output has to be 1. Yeah. And if x is in between 2 and 3, it will provide 2 value. And if x is in between -1 and 0, okay, it will provide -1 value, and up to so on, like that it is moving. So what we observe here? We observe that the domain of f is complete R, codomain of f here is complete R, and the range and the range of f is set of integers. Clear? Collection of all integers. It means the output set is complete set of integer if function is defined from R to R and the function is greatest integer function. How we can draw the graph of this function? The graph of this function we can draw in between here 0, 1, 2, 3, -1, -2, -3, 1, 2, 3, -1, -2. In between 0 and 1, this one will come, okay. But at 1, this is whole is there, because at 1 we have one value, at 1 we have one value, so it will be, and up to here we get same value, and at 2 we have whole two values 2, like that, okay. And here what we have, in between -1 and 0, it will provide always -1 value, and here we have whole, because at 0 we have 0, this one, and here the same thing, this one, okay. Like that we are drawing this graph, okay. We observe that thing, that all the elements in between 0 and 1 provide the same value, 0. All the element between 1 and 2 provide the same value, that is 1, okay. Now we need to prove that the function is not 1 1, neither 1 1 nor 1 2. So for 1 1 means, if we recall the definition, 1 1 means that different element of domain has different image. But we observe that here the definition is not fulfilled. Definition of 1 1 is not fulfilled here. Why so? Because because different element of domain, different element of domain, we have same image. Okay, how? We observe that f of 0 value is 0. Okay, but f of 0.1 value is also 0. F of 0.2 value is also 0. And observe 0 is not equal to 0.1, 0 is not equal to 0.2, and itself 0.1 is not equal to 0.2, because they are at different position on real line, so they are different real number. It implies that f is not 1 1 function. F is not 1 1 function. Now, for onto means, for onto we need to prove this is not onto. Onto means that range equals to codomain. Range equals to codomain. What is codomain? Codomain is complete R, and I told you that it will provide always integer. So clearly the range set is not equal to the codomain set. So here we can say that directly as range set of f is not equal to codomain set of f. Why so? Because set of integer is not equal to set of real number. Understand? Also, elements we have infinite elements in codomain of f, which does not have image. Okay, I hope you understand this question. So it implies that f is not onto function. So from first and second, what is your first? Whatever first, this is our first, and this is our second. F is neither 1 1. F is neither 1 1 nor onto function on given domain and codomain. Okay. Next one. The next question is, show that, again we need to show that the modulus function f such that R2R given by f of x equal to mod of x is neither 1 1 nor onto. Same thing we need to prove. And they also define it. Mod x equal to x if x is positive, or 0 if this one is okay. So again, first of all, I will define completely modulus function. Then I will explain how we can prove neither 1 1 nor onto. So function is defined from set of real number to a set of real number, and f of x is equals to mod x. How they define? If x is greater than equal to 0, it will provide x value, and if x less than 0, it will provide minus x value. Okay. Now, it means that if we are on the right side of origin, the function is governed by the y equal to x line, and if x less than 0, then it is governed by the y equal to minus x line. We can observe here, if we are on the right side, this side, how we can draw the graph? By y equal to x line. This is y equal to x line, okay, or fx equal to x, both are same thing. This I assume y, and here we have same thing, that is y equal to minus x line, y equal to minus x line. Okay, we observe that here, and at 0 we get 0, same thing. Okay, here domain set complete R, codomain set also complete R, and range of f equals to close 0 open infinity, close 0 open infinity. Okay, it means that the modulus function for every input provides the non-negative values, either 0 or positive. So let's start it. 411. We observe that here also the definition is not fulfilled. Why? Because f of minus 2 is 2 and f of 2 is 2. Because f of minus 2, the minus 2 is a negative value, so it will lie in this branch. It is a piecewise function actually. It has two branches, the first branch and the second branch. Okay, it is a piecewise function, and because it is defined in pieces. Okay, if x is less than 0, then we have the minus x, minus of minus 2 is 2. We observe that n minus 2 is not equal to 2. They both are different values on a real line. So they are different real numbers, but they provide the same value, that is 2. Output has to be, output is same. So it implies that f is not 1 1 function. F is not a 1 1 function. Same thing for onto what we have, we can observe here the range set is not equal to codomain set. Here the codomain is complete R, but here the range is this one, close 0 to infinity. Observe range of f is not equal to codomain of f, that is close 0 to infinity is not equal to complete R. Understand? Or moreover, we can say that every element of codomain, every element of codomain of f does not have preimage, like all the negative real numbers does not have preimage. Okay, so implies that f is not onto function. Okay, f is not onto function. Done. Implies that f is neither 1 1 nor onto function. Understand? Now the next question is our signum function. What is our signum function? again we need to show that it is neither 1 1 nor on 2. First is our modulus function, first is our greatest integer function, and the second is our modulus function. Both the functions are neither 1 nor on 2. And now again the signum function come in the picture. The signum function is also neither 1 1 nor on 2. Function is defined from R to R, and like they define, okay, and it is neither 1 1 nor on 2 we need to prove. Okay, first of all, same thing we need to do. The function is defined from R to R. Actually here they directly define, but actual representation is this one. If x is a non-zero, then we need to find the value by this one, and if x is 0, it will provide 0 value. Further, if we define it as a modulus, if x is greater than 0, then it will give x upon x, because modulus we recently defined it 1. If x equal to 0, it will provide 0 value, and if x is less than 1, minus x upon x, it will provide minus 1 value. That's why our function is, if x greater than 0, 1, if x equal to 0, 0, and if x less than 1, less than 0, minus 1 value. I hope you understand this one. Okay, how we can draw this graph? So we can observe also one thing. The domain of this function is complete R, and the codomain of this function also complete R, but the range of f contain only 3 elements, minus 1, 0, and 1 only. Okay, now how we can draw the graph of this function? Observe here. At 0 it provides 0 value. Right side of 0 it will provide 1 value. Suppose it is 1 here. Okay, and at negative integers, negative real numbers, it will provide minus 1 value. Here we have 1, here we have minus 1. It will provide minus 1 value. This is the graph of this function. So same thing we can prove here. We need to prove neither 1 nor on 2. For 1 1, what we have? For 1 1, different element here does not have different image. Again the definition is not fulfilled. Why so? Because we observe that f of x is 1 for all x greater than 0. It means f of 1 is 1, f of 2 is also 1, f of 3 is also 1. Okay, implies that f is not etc. Many more. F is not 1 1 function. Understand? Now for on 2, range, main thing is this one. Range of f is not equal to codomain of f. Why so? Because it is minus 1, 0, 1, and it is not equal to complete R. Understand? So it implies that f is not on 2. Understand? I hope all these 3 questions are clear, and the graph with all the representation, okay, their domain, range. So thank you for watching. If you have any doubt, you can do comments. I will reply as soon as possible.